Hello everyone. So in the today's class we would be discussing about minimum spanning weight trees, and then we will further study about Kruskal's algorithm. This is the algorithm that is used to find out a minimum spanning weight tree from a given graph G. Okay, but before that let's first understand what do we mean by a minimum spanning tree. Okay, so let us consider a graph G which is connected, undirected and weighted in nature. Okay, so just for quick explanation, so undirected means all the edges are not directional in nature. I mean, none of the edges are having any direction. And connected means that any two vertices in the graph are connected with each other by some path. And weighted obviously means all the edges are having some weights associated with them. Okay, so a spanning tree is a tree which is including all the vertices of that graph. Okay, so it is a subgraph which is including all the vertices and is also a tree. We call that subgraph a spanning tree. Making sense? Okay, and the minimum spanning weight tree is that spanning tree which is having minimum weight among all the spanning weight trees. So please remember that for a given graph there can be so many spanning weight trees, but the one which is having minimum spanning weight tree is the one which is having minimum weight. Making sense? Okay, so now here is an example of a minimum spanning tree. Suppose this is a graph in which you can see on the screen. They are having six vertices, and all the edges are associated with some weights which you can see. And suppose for this graph, if you are supposed to find out what is a minimum spanning weight tree, it is shown here. So as you can see that this is a tree because there are no cycles found within this subgraph. Also it is including all the vertices of this graph, so it is a spanning tree. And as I will show you in the coming slides, it is also a minimum spanning weight tree because it is the weight of this spanning tree is minimum of all other spanning weight trees in this graph. Making sense? Okay, so now we are going to understand what is Kruskal's algorithm and how does it actually work. So Kruskal's algorithm is one of the greedy algorithms, and it is one of the greedy algorithms. This class which we discussed quite a couple of classes back. Okay, so this algorithm suggests to first sort all the edges into non-decreasing order of the weights. Okay, so after sorting out all these edges, then we consider a spanning forest, or in other words you can say that we consider the same graph G and we remove all the edges from that graph. So what we are left with is the graph G with, or G dash, having all the same vertices of G but with no edges. Now in this graph G dash we are inserting the edges from in the same order, that is the same non-decreasing order. So this implies that the first edge to be inserted is the smallest weight edge, and then you will keep on inserting edges. While inserting every edge, you need to make sure that it shall not form a cycle with the pre-existing edges in the spanning forest. Okay, if it forms a cycle, then we have to reject that edge. And finally we will stop as soon as we include the n-1 edges in the spanning forest, and here n is the number of vertices in the graph. Okay, to make it more clear, let's consider an example. Here comes an example. So this is the same graph which I showed to you in the previous slides, and if suppose we are required to find out a minimum spanning tree for this graph. So as it was mentioned in the algorithm, we first sort out all the edges in non-decreasing order. Now suppose we have the sorted list, we pick up the first edge, that is the smallest weight, having 10, and then we put into a spanning forest which was initially all the just vertices. with having no edges. So the first wedge included was a 1 2 edge having 10 weight. This is the one. Then next step, we choose the next smallest edge, is having edge 15 between 6 and 3 vertex, and this is included here. It is not forming a cycle, so it can be included. Like this way we proceed, and then we include other edges and we can see that this spanning force is increasing. Now look at this edge 1,4. This is forming a cycle with the vertices 1 2 6 4. So we need to reject this edge and we have to proceed further, and then we pick up this edge 3,5, that's 35, and as you can see, it is not forming a cycle. So in this way you have got as minimum spanning weight tree, since you have included 5 edges, that is 6 minus 1, that is total number of vertices minus 1. So this indicates that you have obtained a required spanning tree, minimum spanning weight tree. So the basic crucial step in this algorithm is how to check whether a cycle is getting formed or not. So for that you need to use a set and union method, according to which you consider every tree, or you represent every tree by a set, and so and all the vertices of the tree are the members of this set. So if the two members or two vertices u comma v, if they are in the same set, this implies that they are already connected, and if you include the edge between them, then that will form a cycle. So then you should know that you have to reject this edge. Okay, and suppose that they are not in the same set, they are belonging to S1 and S2, then we perform the union of that set to combine and create a new set S dash, and now which will indicate that u and v are no more disconnected. So this way we perform the algorithm. So any doubts, and let me know. Okay, so the small exercise for you, just calculate the complexity of this algorithm while you go to your home, and also try writing a pseudocode for its implementation. Thank you guys, have fun.